Hello, everyone. Thank you for coming. I hope you had fun. We had really great, amazing talks so far. And my name is Edmo. I'm a software engineer at Elastic and an OpenTelemetry collector contributor, where you're going to find me normally contributing to OTTL and transform processor. So how many people here are familiar with the OTTL? Raise your hand, please. Well, a good amount of people. And how many people find troubleshooting test OTTL easy? No one. Well, we got one. Well, hopefully by the end of this session, we're going to be more confident on doing that. We're going to give you a tool that's going to help with that. But before, let's see what's OTTL and why do you need a playground for that? So OTTL is a powerful domain-specific language designed for interacting with your data inside your OpenTelemetry collector. It gives you access to all the OTLP fields or the data that's passing through your collector, your logs, your traces, your metrics. It has a rich set of building functions, more or less 100 at the moment, and you can use all of them for changing your data or for filtering your data. It also supports common query language features such as conditions, logical operators, and so on. So let's imagine we want to change a log data and we want to set didn't work. And we want to set the severity number of my log to error. If I have a body string, and that string has an error word on it. How can I do that with OTTL? So this is more or less how a statement for doing that would look like. So we do have two parts here. One is a function that changes my telemetry data, in this case the severity number, and an optional condition that determines if that function should be executed. So this is more or less how we would do that. But where can I use it, OTTL at all? So yeah, those are the primary components where you can use OTTL at the moment. We're not going to go through all of them today. We don't have time for that. But we're going to see two examples, one of the transform processor and another of the filter processor during the demo. So I have my OTTL statement. I did set up my component. How can I ensure they are doing exactly what they are supposed to do? How can I ensure my configuration is really working? So currently, we have two options. So one is the debug exporter. When you enable the debug export and set the severity verbosity to detail, this export is going to start printing out data to the console. So you can use that data to compare with your input and determine if your transformation is working. As you might guess, that might be very hard depending on how big your data is or how complex your statements are. It also shows exactly how the collector in the OTTL sees your data, which is really important because you should use the same field names on your statements. And they might be different from the data you see in your final destination, on your vendor tool. Another tool we have is the debug logs. So when you enable the collector debug logs, you're going to start to see a lot of OTTL logs, and they are very useful. They might contain the statement and condition being executed and the underlying data, the data that's being modified or the data that's being filtered. Depending on the components, like the transform processor, you might see a step-by-step account for processing as well, which might include, for example, your data before running any statement, and the data after running each statement, so you can identify which one is not working. Well, it's very useful. The debug logs are amazing, but it's also very verbose. When you turn on the debug logs for the collector, that's going to turn on the debug logs for everything. So you're going to see a huge amount of data being printed, and that's crazy for filtering and find the logs you care about. So both tools are very useful. They are, the main tools we have right now, but we want another option that's going to make these analysis processes easier, and that's when the OTTL Playgrounds come into play. So the OTTL Playground is a web-based application that allows you to experiment with OTTL in components in a kind of sandbox environment. So you don't need to run a collector, you don't need to put your production environment in risk testing statement. I'm not saying you do that. Everything runs in your browser, and you get visual results. So you can focus on what matters. You don't need to focus on filtering logs. It's built with WebAssembly, which means the code that runs under the hood is the same as a live collector, so you can expect to get the same results as well, the same errors as well. And it allows you to share that statements, which improves a lot the collaboration with the community. So yeah, we're going to do a live demo. If you want to scan that code or just type OTTL.run, I think it's faster. Yeah, let me just switch the screen here. All right. So as you can see, the UI is very simple. That's all. We don't have more pages. That's all you need. We got two drop-downs on the top of the screen here, where you can select the collector contribute version and the component you want to test, the component you want to run. So that configuration should be done on using this panel, where you're going to insert the snippet of the processor. And finally, on the bottom, we're going to find the OTLP payload in the JSON format. So yeah, you can read it and understand what that is. And that's all that we need. And the good news is that we don't need to start from scratch. You don't need to type all the data load if you want, just test some small statement. The playground, it supports a lot. It provides a lot of examples of common operation, real-world common operations that you can use as a starting point. So let's select one, very common one, which is parsing JSON log bodies and use that data to enrich our OTLP log. Yeah. All right. So whatever we select the example, we're going to get both field, the configuration and the data. So before I look at the statements, just looking at the data, we have a log entry here, and the body of my log is a JSON string, and I got a timestamp in a string format as well, a level, and a message. So let's look at the statements, what they are trying to do. So the statements are basically parsing that body, put that into the cache, so I can reuse that data in other statements, and it's parsing again the timestamp from a string to time, so we are setting my log time, setting my severity, and finally replace the body with the message field, because we don't want the JSON anymore, yeah? So let's run this and see how the results are displayed. Yeah. So this is the GIF result, and it should be very simple to understand. It's a GIF-based comparison of this data and the transformed value. It means this data after applying those statements. So looking at this change, I can tell that my statements are probably working. I got my body content replaced by the message field. The severity text field was added, and the time was updated. So I can tell, yeah, it's working. I got pretty excited when I saw this at the first time, I have to say. It made my life so much easier. And yeah, but if for some reason you do not understand this view, I don't know, maybe the severity text is not clear for you, you can use another view that explains this with text instead of colors and the GIF-based notation. So you can think about this view as a JSON patch that should apply to your original data, and the result will be the transformed data. Might be a little complex to understand, but it's much simpler, actually. So let's see the severity text example. So I'm not pretty sure it was that, but if I read the description, it's going to say add a new property. So that should be the action. It means it's a new property. That's different from the body, which was a modification. So you can use that view. And finally, if you want to see the raw data, you can use the JSON view that is going to give you the raw data. And yeah. Finally, it also going to provide you the execution logs, which are the same as the debug logs, but here they are much less verbose. We don't have logs from other components or log from other data transformation. Everything here is related to your execution. So the Playground also supports testing filter processor configuration. It works exactly the same way as the transfer processor. So I'm going to do a quick one here. It's just dropping debug and trace logs from my pipeline. This is a common one. So it works exactly the same way. I selected the example. I got both panel field. So I'm going to run, and you can see how the results are displayed. So again, looking at this screen, I can tell that my log with index 1 was dropped. Is indeed a debug log, so it looks right. But I still want to check the other entries, the remaining logs. So I can mark that option as well. That option will basically show the data that wasn't changed, so I can compare and check if that's right. In this example, yeah, we can see it's an info log, so yeah, it should be preserved, so it looks correct. And finally, if you want to share this with someone, you can click on the cop link button on the top of the screen, and that's going to generate a unique link that you can share, and people can easily reproduce the same scenario. All right, let me. Oh, that worked well. So what's next for this project? Yeah, we have a few features in mind, which includes adding support to the routing connector in tail sampling, so you can experiment with them as well. We want to improve the visual results, so the easier they are, the less time you're going to spend troubleshooting your statements. We want to support kind of embedded view as well, so you can put that in docs, blog posts, whatever you need to run OTTL or, you know. Regarding the project, it's an open source project. We really want your opinion. That's true. If you have some ideas in mind right now, if you have some problems in mind right now that's not covered by the tool, please go ahead, open an issue, open a suggestion. If you want to collaborate with code, even better. And yeah, any kind of contribution are very welcomed. And finally, I'm going to leave here a few links that you can scan and learn a little bit more about the components we discussed today. And yeah, and that's all for today. Thank you very much.